Section 3.4 histogram. We'll discuss with the example. So this is data t values. This is a class interval. Initially, we want to look at when we do a histogram that this class interval is continuous. Yeah, 30, 30, 35, 35. Yes, there is no discontinuity. It is continuous. If it is discontinuous, we want to make sure that it is continuous. And this is the frequency. But first of all, I like to discuss something approach for these histograms. I'll find the midpoint of this one. Midpoint. So midpoint is going to be 25 to 30, 27.5. This is 32.5 in the midpoint. 30 plus 45, 37.5. And 40 to 50, 45. And 50 to 60. Let me change, this is 80, 50 to 80. It is going to be 65. So those are the midpoint. So if I draw a curve, graph, actually not curve. Let me draw the curve. Now before I draw this graph, let me ask a question first. What is the probability of t in between 25 to 30? How can we find the probabilities 25 to 30? So there are 55 frequency. Total frequency is 200. It is going to be 55 out of 200. Assume that we want to find a probability in between T40, T50. So how do we find 40, 50? So the frequency is 32 and out of 200. Now this has become a probability. The relevant frequency divided by total frequency. So now if I draw into a graph, so I draw a graph here, t and the frequency. So I can't write 25 to 30. Because of that, I select 27.5 midpoint. So what is that frequency is 55. And 32.2, that frequency is going to be 39. And the other one, 35 to 40, which is 37.5, 68. So actually this is okay, 68. And then 45 to 50, that is going to be 32. But this is 32. And this is going to be 65. 6. So what is this graph? This is a spike graph. Now, extended question. So 25 to 30, 55. Assume that I want to find the probability of 25 T27. Then how do we find? You have this knowledge. So then I need to find 25 to 27 number of people. It has to be up to 25 to 30, 50. Then 25 to 29 less than that amount. So in that case you can use the interpolation. Up to 30 it is 55. Up to 25 it is 0. Then you want what is 27. Up to 27. Then you can get the relevant frequency from here. Then you will get this value, and then Yeah, that is the value. From here you will get, and let's say this is this value is alpha. It means this difference is alpha over 200. Likewise, if I ask what is 20.27.1, so likewise it is more difficult, critical. Still we can use this method and we can find. But if we have a different presentation, so much easier method, so yeah, it is good. So this is where histograms come to effect. Now instead of this one, in a histogram, what you can see, so normal spike, you will see this as a area. So now frequency, we are going to express in terms of area. So then area we are going to represent now earlier height. The spike mean height. From height we represent what? Frequency. Now it is area we are going to represent frequency. So when we are going to represent frequency with the area, so what is the first requirement? Because area should be proportional to frequency. This is the way we want to adjust this situation. It means total area has to be proportional to total frequency. So this is the way. If we want to represent frequency from an area, so in other way, if we want to represent as a frequency from an area, then it should be follow this rule, right? Area should be proportional to frequency. Frequency, how do we measure from to measure frequency? We use the number line, one number line. To area measure we use how many number lines? Two number lines. It means this is a 1D reading and this is a 2D reading, two dimension. So this is where we turn 1D to 2D. 1D data we are going to read in terms of 2D. So we should have this relationship. Area should be to have this relationship. Area has to be proportional to frequency. Then only we can do now. We found out the probability here. The objective of this histogram, because this is the initial stage of we are going to make a probability distribution. So assume this is 55 over 200. So 55 over 200. So what is this? 25t 30 probability. The same thing we are going to write. The area belongs to 55 divided by total area. Instead of frequencies, we are going to turn this one into a in terms of frequency, we are finding the probability into a from a area. Assume I am dividing this. This is interval 25 to 30, 25 to 30, and 30 to 35, 35 to 40, 40 to 50, and 50 to 65. So I am dividing this to 25 to 35. 150, 110 boxes, small boxes. So in here 110 small boxes. Likewise, when I divide this one to small pieces, so this is my slicing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 17, 20, 21, 22, 22. Likewise, I count in everything. Then I count here there are 78 small boxes. Then I am dividing this one to small boxes. This boxer size has to be same. Can you see that my boxes are not same? So then I am wrong. So it has to be same. So I am assumed they are wrong now in this case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 100, 101, 109, 100, 136 box here. And then I am doing the same thing to here. Then I start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 13, 13, 31, and 50, 51, and 64 boxes here. So now I start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10, 9, 11, 12. So there are 12 boxes here. So I turn this graph into a small boxes. Now I count the number of boxes. Now what is the total number of boxes? 110, 78, and 136, and 64, and 12. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I need to find the total number of boxes. So there are 400 boxes. Now I want to find the probability of 25 to 30. Probability of 25 to 30. Okay, 25 to 30, how many boxes there? 110. And total number of boxes? 400. That's how we need to find. So it means when I divide 55 divided by 200. Now can you see that? I work with this one. 25 to 30, number of frequency, 55 out of 200. The same thing I work out, I turn into an area. Under one rule, area is proportional to frequency. And then I counted number of boxes out of total number of boxes. Still the same. So this is the task of a histogram. So you need this knowledge when we start doing probability. So when you don't have this knowledge, you don't know what is going on. You start doing the chapter, but you don't know what is the real meaning behind it. Now we need a smooth one. So how do we get a smooth one? We do a polygon. We take the middle of these points and we merge middle like this. Now I am going to complete with these small boxes, this area. And this is a now we have to count total number of boxes. Now it's this is going to be changed. It's going to be, let's say, 525 now. Then if we want to find 42, 41, so you want to find T 42 probability 41. Then you want to count 40 to 41 box 1, 2, 3, 4, 5 like this. Let's say 21 box, and total number of box 525. Then you will get the probability. Now you are going to, then what will happen? You are more smooth in this one. Then you will still put in these small boxes, and then we smooth this curve. But the technique of smoothing is, instead of taking big big areas, we will break into two small areas. This one probably like this. The class width we are making more and more smaller to smooth. It's not the way of smoothing like this by drawing like this. That is not a technique. The technique is we are making more and more. The class width is smaller. So we have assume this one. Then we are breaking into a smaller class width from here, like this. When we make the class width smaller, the curve is getting more smoother. Otherwise, not by drawing. So then, when this box, so basically histogram is the one box, lot of box. The width is I am making to smaller. Basically, we are sending limits 10. This height, let's say this width is w 10 to 0. So you can study. This is histogram estimator and kernel estimations when you if you do uh, in uni or the masters graduate. Now for this topic is important thing is area is proportional to frequency. Now you know what is the reason behind it, otherwise it is meaningless. Mathematics you need to learn with the meaning, otherwise you can't understand, you will stuck somewhere. Now area is proportional to frequency. Area of a bar basically. Okay, area. Now the proportional sign we can take by putting a constant. Assume that P proportional to M. So how I'm going to make an equation? P equal K times M, introducing a constant. K is a constant. Likewise, area is equal to K times frequency. This is the technique we are using to get rid of, because why? When you divide area and frequency, it has to be constant. That's the way we need to develop this equation. So now usually we work with k equal 1. then area is frequency when k equal 1. So area, what is this area? We are using the shape box. Area of box equal frequency. So area of box means height multiplied by width is frequency. Now, actually, if width is fixed, height equal frequency. That is how we did in GCSE and before that year 7, 8 sum. When we do small sums, height and frequency. Right? There are 5 cars, so then we are writing 1, 2, 3, 4, 5. 5 cars. Denote 5 boxes. Picture diagram. Right? So height is frequency. But now here width is changing now. Then when the width starts changing, we can't tell height is height now because it is also a height, but it's a different height. For example, if this is, let's say, frequency is 100, and I'm going to write with this one 20, and this value is going to be 10. Right, keep this 100. If I change the width to 25, then this is going to be 4. Sorry, this is going to be 5. 5 times 20, 100, 4. And if I change width 50, then this is going to be 2. So height is changing accordingly. And we will name this height as a frequency density. Frequency density times width is, we use class width, equal frequency. But still, if it's difficult to get your head around these words, frequency density, you can stay with the height. When you want to think, you just think, turn this frequency density into a height and think. Then you will not get confusions. In other way, frequency density equal frequency divided by class width. So we want to divide frequency by class width. So what is the class width here? 25 to 30, 5, 5, 5, 10, and 60 to 50, 10, or 60 to 80. This is 30. So then frequency density, I write short form. How do you find? 35 divided by 5. Frequency divided by class width. So this is going to be 7. And then 30 divided by 5. This is going to be 7.8. Then 68 divided by 5. This is going to be 13.6. And 32 divided by 10. This is going to be 3.2. And 6 divided by 30. This is going to be 0.2. Now you have to be smart when you select this area. So this area should be From this area you will be able to represent 0.2, 3.2, those values. We use this word frequency density because it is depend on frequency. I think 35 divided by this is I'm going to change this value to 55. So 55 divided by 5 is 11. For a reason you will see that later why I did that change. 55 divided by 5 is 11. This is a graph. Can you study this graph? 25, 30, 40, 50, 80. This is T and frequency density 11. So I show this one 25 to 25 to 30. Frequency density is 11 and class width is 5. So I'm going to give you a question now. So these all boxes size are same. This one, this one, this one. So I see. Can you calculate the frequency belong to these four boxes? So I wrote 60 and 70 as well. I think I need to do some 25, 30. This is 35. So divide this 40, 45, 60. So right. So I just want this area 35 to 40, 45, 50. Please rethink again. What is the frequency size belongs to those four boxes? So we need to find the frequency of one box. So class width is 5. So we can find this is class width is 5 and frequency density is 1 box, and then 1 times 5, 5. So the one box, this is area, always um, yeah, class width. So better to have this equation, frequency density times class width equal area equal frequency. So this will reduce if you are in a difficult situation. Use this one. Go through area because this is all 1D, 1D, and this is 2D, and this is 1D. Yeah, we know that when one dimension multiplication of one dimension make two dimension, but when you read by brain, this is you are reading as a single dimension value. So now 1 and 5 make the area. What is this area? 5. One box, and this one box is 5. Go through the area. So one box is 5. Then how many boxes? 5, 10, 15, 20. So they are talking about 20 frequencies. Now next one is this. I need to calculate this one, this one, and with the 1/4 of box, what is the frequency. Now how do you do this one? Uh, Frequency density, I wrote this equation, class width equal area times frequency. Now I divided this one box into 4 small boxes. Now that big boxes doesn't work here. Now we only small boxes works because there is one small box here. Then you can come with like this frequency density, that is 11 here, times okay, actually we know that okay, we don't need to go this way. Frequency, we know that this is imply 55. If we know the frequency, we know the frequency. Then area is small boxes. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, 11. 1, 2, 3, 4, 5, 6, 7, 10. And okay, did I mean 1, 10? It has to be 11. So 1 boxes represent 5. We calculate 1 times 5. Now, with the frequency is 55, and area. Now you can write 11 big boxes. 11 big boxes. That doesn't work now because we need small ones. Then we have to come to a small ones. It means 11 times 4, 44. 44 small box is 55 frequency. Then one small box is 55 divided by 44. Then we need how many small boxes? 4, 8, 1, 2, 3, 4, 5, 20, because 4 times 5, 20, and 21. Then 21 small boxes is 55 multiplied by 44 multiplied by 21. Then you will get the frequency. In here I saw that 55 frequency given. Otherwise, how do you do this sum? Then you can see that frequency density is 11, class width is 5. So then you can find frequency is 55. So how many small boxes now? 44 small box. Then one box is 55 divided by 44. Then here 21 boxes be small, we need 55 divided by 44 multiplied by 21. If the frequency is not given, right, then you can get this one and the class width, and then you can get the total area. Or this is also right. The same ratio will get. Instead of that, you can take this one. 1 times 5 is what? 5. 5 give for how many boxes? 4 small boxes. One box is 5 divided by 4. The same answer you will get 11 times 5, 11 times 4. Always, if we have a problem, if we are confusing, put this area into middle, because this area also in the middle as a variable. You are getting confusion when you lost this area concept in between those two, because these all are single, one dimension, and 1D, and we will lose the conscious of 1D times 1D to area, and then the histogram become difficult. So I'm talking about this sum is about example number 5 in the book. Example 5 on this chapter. Uh, you can see the sum in the book. Uh, that's why I write this is 55. And now the first question is draw a histogram and frequency polygon to represent. You can see the one. So when you do the frequency polygon, so you want to get the uh, middle points and just merge the middle points as on the picture, as on the diagram. In this sum, example 5, part A you can see, and part B, there's a shaded area. So we want to find the shaded area. So then the first consider the big tower and the small one with the shaded. So the class height is frequency density is 13.6 multiplied by according to this one. Class width 1 is 40 minus 36. So then we will get that frequency, and then we need to add to this one again. What is the height? Height is 3.2. 3.2 frequency density, and the class width is going to be 45 to 40. So 45 minus 40. So 3.4 times 5, and this is 13.6 times uh, 4, and you will get the answer as 70.4 students. So we use this one, frequency times class width equal frequency 2 times for this one. Frequency density, which is height is 30.6. You can think, if it's confusing, think about height. Height is 30.6 and the width is, you can see that 40 minus 36, and the same as height is 3.2 and the width is this one, so 70.4 students. One more special fact of the histograms in this stage, but later we will change it to the other parametric, non-parametric. So this is we use histogram for grouped continuous data. That is one thing we need to know. In example 6, so when you read this sum, the first question is given a reason to support the histogram to represent this, your reason to support the use of a histogram to this data. So there are due to, so because of grouped continuous data. Part B, write down underline feature associated with the bar histogram. So we know that area is proportional to frequency. Or area is k times frequency. K is a constant. All right. and C. Show that the each day is represented by an area. Alright, okay, there's a history given. So 16 to 18. There is a box. This box length is 2 centimeter and height is 2 centimeter. And the frequency is 8. Uh, this is going to be frequency is 8. Can you remember that we work with the 11 boxes equal something 55 and one boxes is 55 or 11. So in there I measure it with number of boxes area. So now they give the instead of that the real distance 2 centimeter and 3.2 centimeter. So this area is represented by total area is 2 times 3.2. Now then this is going to be 6.4. So 6 cm square represent uh, 8 frequencies. So 8 days represent by 6.4 cm square. Then 1 day is represented by 6.48, that is 0.8 cm square. That's why I said that it is just write this one with the area for frequency density class with area equal frequency. So now the part D, given that the total area under the histogram was 48 cm square, find the, so we have the relationship again, 6.4 cm square represent 8 days. So we need a number of days. So then 1 cm square represent 8 over 6.4. Then we need how many? 48 cm square. So this is all year 2-3 knowledge. 10 apple is 25 pound, 1 apple is then 3 apple price. 10 apple is 25 pound, find 3 apple price. So 1 apple price is 25 divided by 10, then 3 apple 25 divided by 3. So 8 divided 48 is represent 8, then 1 is 1 apple is so 48 apple, then 8 6.4 48. Your answer should be 16. We'll discuss the exercise 3D now.